got sum and differences of functions. So we'll start with two simple functions. This is our quadratic, almost our parent function. It's very simple. It hasn't been transformed at all. The origin, the vertex is at the origin, and if we were to graph it, it's like the most original way we could have done it. We move 1 over to the right, we square it. We move 2 over to the right, we square that value. Okay, so simple function. The next one is a horizontal line at the value of 3. And what we're going to do, algebraically, we're going to play with these two functions and see how their y values are affected when we put them together and we subtract them for each other. So first we'll actually combine the two functions, because if you see here, I've already set them up. We have the combination of g at x and f at x, and g at x is our parabola and f at x is our linear. And same idea, this one we're going to subtract the two functions from each other. So algebraically, we'll take a look at what that would be. We would give the new function, after we add them together, another name. So maybe we would call it h at x. Okay? And the way they might represent it is h at x is equal to g at x plus f at x, which has not given us anything for our function. And what we're going to have to do is simply just plug in our functions into those values. So g at x is our x squared, and f at x is our value of 3. So we're just going to simply replace those values. Okay? So our new function, h at x, is equal to x squared plus the value of 3. There's nowhere to simplify. These terms are as simple as they get. And if you're very good with graphing quadratics, you realize that this is just a quadratic that's been moved up. The vertex has been moved up 3 units. Okay. Another way, let's go another one. We'll call this j at x. J at x will be very similar. We're just going to subtract the two functions from each other. So g at x minus f at x. And again, if you're good with quadratics, you'll recognize very quickly that this is same idea. The only difference is it's been moved down 3 units. Okay. So algebraically, how this could play out. If we were to plug in, let's say the value of 1 for g at x. If we plug in 1 here, 1 squared is the value of 1, so g at x would be equal to 1 at that point. If we plug 1 into x here, does this do anything to our f at x here? No, it won't change it because there is no x to substitute a value. And so f at x is still equal to the value of 3. Okay? And g at x is actually equal to 1 plus 3, which would give us a value of 4. And we can even test this out on our graph to take a look at it after when our x value is 1. And the same idea here, we would have 1 subtract 3, so we have a value of negative 2. So algebraically, we can even set it up like this. And if we were to quickly look, if we plugged in 1 here, we have 1 squared plus 3 gives us the value of 4. And same idea, if we plug 1 in here, 1 squared minus 3 gives us the value of negative 2. So you can carry this out with any x values. We could have an x value at 3. Our g at x would be 9. This would still be 3. You'd get 9 plus 3 is 12. Or 9 minus 3 is the value of 6. We could use the value of 10. Gives us 100, 3, 103, or 97 are our values, right? So graphically, what does this look like? We have our two functions. We have g at x is equal to x squared and f at x is equal to 3. We can, and I hope this will let me build it this way, is equal to g at x plus f at x. And it puts the function together. And if you notice, the vertex of our new function has been shifted up to the value of 0, 3. The stretch, the compression, the horizontal movements are all the same. Nothing's been moved except that the vertex has been shifted up 3. Okay? And with that same idea, j at x is equal to g minus f at x. Same concept. Only difference is in this one, we've moved it down 3. And if we were to check, remember some of the x values we used were, we used x at 1. So I'm just going to put a vertical line at, whoops, wrong value, when x is 1. And if we look at our two functions, okay, at our, when we subtract it, our y value would be negative 2 when we subtract the two functions. When we add the two functions, our y value is 4. Okay, and we knew at our original ones we had a value of 3 and a value of 1. So it's a simple idea. We've added 1 and 3 together to get 4, but we subtract 1 from 3 to get negative 2. Okay, so this is kind of showing how these functions algebraically relate to each other. And these are simple ones, and a lot of the functions you use will probably get a lot more complex. But this is the general introduction to sum and difference of a function.